In this video, we'll see how we can design an agentic system that resolves customer tickets or issues. So there are different variations for this, but some of the common ones are that anyone can call a particular service that they have, and then the customer issue is resolved by a human agent. But then how can we replace that human agent with an AI agent and then still solve the user's query? So every time every issue doesn't require a human intervention. Some of the issues or customers that we face would be like, you have a service in your house, you want to reset your password, you don't have admin access, stuff like that. For this you don't need a human intervention. It could be an automated process that would be completed by an AI agent also. So these types of issues is what we can solve using creating an AI agent for this particular problem statement. Okay, so similar to the previous videos, what we are going to do is we are going to have our system approach as the first thing would be goals. So the goals for this particular design would be automatically resolve maybe more than 60% of issues that are getting resolved by human agents right now, but it should be completed by the AI agent. Okay, so examples would be like refunds, password reset, maybe order tracking. So stuff like this could be resolved directly by an AI agent. And if this happens, if you're able to do this, what is going to happen is it's going to reduce MTTR. What is MTTR? Which is mean time to resolution. Okay, so this is reduced and we save money, we save energy, we save a lot of people who would be doing this job. Then we don't need that many people, we would use less number of people solving the tickets. Okay, so these two things are can be added. We can add more stuff to it. So like we need zero hallucination. We'll try to have zero hallucination, like for prices, discounts, policies. We don't want the AI agent to take decision on the price, to lower the price for a particular customer or give them huge amount of discounts, just that it wants to resolve that ticket and keep the customer happy. So we don't want to have that amount of autonomy to the AI agent also. So, but it should not also give false information. So something that is already there in your policies should not be changed just because you want to resolve the ticket. Okay, so that's important. But if but we have to set some rules for this. But if it is not able to resolve the issue, the first thing that we need to do is we need to redirect to a human agent. When AI cannot resolve the ticket. Fair, right? Because we don't want it to go into multiple loops where the agent is not able to understand anything, and then the customer is frustrated, and we have a decreasing customer satisfaction metric. We don't want that, right? Out of all of this, we should understand that the customer expects a response in a very quick way. So we can have latency less than 3 seconds for every question asked, or for the entire conversation. Every conversation that the user would be having with the AI agent is within 3 seconds. Sometimes a bit more is fine, but we'll try to make this as one of the metrics. The second part is the last part I would like to highlight here would be the handoff accuracy. We need to maintain this as high as possible. If it has to go from one agent to another agent, or to a human agent also. Basically, what we want is summarize in a concise way and then pass it on to the next agent or pass it on to the human agent. We don't want the customer to repeat what the issue has been or what all conversation it has been doing with the AI, right? It should be passed on, and then the handoff also should go to the human agent if we come to a situation where the point number 4 has to be executed. Okay, so these are few goals. There are many more. It's a very open-ended problem, and it doesn't solve everything, but then you can create multiple agents who can solve different issues. Okay, having said that, let's move ahead with the scope. What can we design for a system like this? What all things can we consider? Okay, so the first thing would be we need a chat interface. We won't go with the voice. The reason being is we'll have to have the speech to text, and that we need to consider the accuracy of that too. So for this problem, we can just go with the chat interface where there's an agent enabled who figures out the resolution. Okay, that's the how the user communicates with the AI agent. Okay, then we also need something as understanding context and respond accurately. This could be one of the context retrieval nodes that we can create. The third thing would be if the customer is not able to explain proper in proper language the issue what they are facing, then it should go back and ask clarifying questions. Okay, once it does this, we also have to, let's say they understand the intent, right? So with the chat interface, understand context, we can also put here intent and understand context, get all the context from different databases, and also understand the intent, what the issue is, right? And then ask clarifying questions around it. That is important. Then next would be what if it's a very common issue that you're getting. Let's say there's an outage in your area, right? A lot of people who are going to call you are going to ask you the same question. So what we can do is, if you have already answered it, we can just check whether similar issues were already answered before or not. This is important because so that we don't actually start the entire flow, we just check if something similar has been answered before in a particular time span, and we can engineer around it as well. That could be one of the scopes. Then the last, not the last, let's say let's add a few more in this. Let's do tool execution, which means it has to grab information from different tables, databases, documents, and all the data that you have in your enterprise system or anywhere. And you can do this with maybe RAG. This would be a good way to do that. You can do RAG, and you can have a tool that does RAG. You can have that combination as well. So that would be one. Then the entire journey of a customer from the analysis of the intent to actually giving you a resolution, we should always track the sentiment. And let's add the urgency as well. What if it's an urgent thing and the AI is not able to solve it, right? So we should understand this, and if and we can route this to human for quicker resolution. Okay, so understand this, that the urgency and sentiment is really important, because the customer once angry you lose your customer. Okay, so we don't want to happen that. We just would reroute it to a human, and the human might just solve the issue in a quicker way. Can happen, right? And but then if you do that, what if the human is not available? So maybe a callback functionality. So if it could be more like if human not available right away. So they would give you a call. They would say that, hey, now there's an agent available to resolve your query, something like that. We could have that, and this would be the entire workflow, at least for this particular video. The last thing that we have seen in previous videos also is guardrails are important, which are just rules, right? So what type of rules should we have in our system is important to make a note of that. One would be never authorize high refunds, or credits, maybe discounts. You know, high. It could be, you can give a range like more than maybe $100. You shouldn't authorize this without human approval. This makes sense, right? What if it does it twice or thrice and then it goes back to your previously solved issues database, and then when someone new calls, now it is still doing it? Okay, so the human approval should always be there for stuff like this. Then we should always custom mask the customer data, right? All the PII information should be hidden. We don't want to show the entire credit card details, maybe SSN, stuff like that. We should not show it. Maybe the last four digits and stuff like that would work, but never show everything to the user as well. And make sure we have a finite loop. We don't want it to go into infinite loop, so preventing excessive infinite intent loops actually, if unresolved. If unresolved, just route to a human. So you can have like 3 or 4 iterations of your entire system saying that, hey, I did not understand your question, let me try this again, and if I'm not understanding it for 3 more times, let me route to a human agent. Then that would do it. For this entire journey, the tone should be consistent. This would give a high customer experience, right? So we could have these 4 rules for now and these goals. I think this is pretty much covers a lot of things for this particular design. There are a lot many things for this particular. It's a very open-ended problem statement, but you can narrow it down if you take an example and do it. Okay. Now let's start designing our system. So as discussed, the first thing that we would have for the user is the chat interface. So in this chat interface is what the user is going to ask his or her query. And for this particular aspect, we wouldn't be talking much on how can we authorize the user, but then we can have a node over here which will do authorization. It would authorize the user so that we know that someone who has the service is talking to the AI agent. Okay, so once the authorization is done, we need to actually send whatever the user asked to start the flow. So we'll have the first node would be something like this. We'll have a bigger node, and it could be an orchestrator agent which will orchestrate what type of query it is and which path we need to follow, which is important because we don't know what the user is going to ask, right? And we should also have the same as intent analyzer over here. So we should know what the intent of the user is, what type of questions it is asking, and we should also know how complex the issue is. Because if it's really complex, we should make sure that we don't waste time using our AI flow if it is not going to solve that query. We should directly go to a human agent from this particular stage itself. But if we have seen this issue before and we know an AI agent can solve this, then we start our flow. Okay, so it goes over here. Now before it goes further, what we can add over here is we can quickly add a small block which would be maybe our documents that we already have. So in this type where we could have these are docs, and we could also have database, right? Something like this, which would be the DB. And all of this could be inside one big structure. And what we do over here is we perform RAG here. And this RAG is done on previous issues or tickets. It means when the user asks a question, it goes to the orchestrator agent, and we can have one flow that goes to this particular path to look for similar issues. Maybe something very similar has happened on the same day, right? But two customers have called. So you don't have to start the flow again and again. You can just look at the latest issues and say, hey, a lot of customers are facing the same issue, and this is the resolution. Either we are going to resolve it, it's a very big issue, it's going to take some time. We have raised a ticket, the concerned team is aware about it, stuff like that could be the response directly without ever starting the flow again. Okay, so this helps us to minimize most of the stuff, so it would be like already answered before. Okay. So this would be a small loop that goes and checks, but then what if it comes over here and is not able to understand your query? So it goes back to the chat interface and tells, hey, I'm not able to understand, so please clarify. So you start asking clarifying questions here so that the intent is understood before we go further. Okay, so assuming that happens and we are all ready with the question and we have understood what the user is facing, now we need to categorize this. It's important to know that what type of query it is. Is the user asking just to reset my password, or if the user is telling that, hey, I need to suspend my service, I don't require your service anymore. If something like this is there, then it should categorize that, right? So we could have one intent here. So intent category 1. So based on what type of problem you are solving, it could be over here. So we could have multiple categories for our system. So this would be 2, and this would be like, if you're like 6, 7, 10, 15 categories, these would be 3 n categories that you have. So from this orchestrator agent, we have your move it to one of these categories. Okay, fair. Now we know what type of issue it is. Now next node is, now we need to actually find the answer. So before we find the answer, do we have all the information to answer the question? Is the question we need to ask ourselves, the person who is designing the system needs to ask. Okay, so we create another node. This node could be like a context retriever. So the main task of this particular node would be get all information of that particular customer. So get customer info, its orders, previous orders, maybe tickets, whatever they have raised before, because maybe they're just following up on a previous ticket that they raised, maybe something related to billing, so just get that data as well. So a lot of uh, things can be gathered based on the user. We have already authorized the user, so we know who that person is, right? So once we get understand what the intent is, we based on this intent we start gathering all the information. Okay, so let's say it goes from here, it comes here, so whichever it comes over here. Okay, and how do we get all this data? This data is stored in your enterprise databases, right? So you would have a database over here. So something like this. So this is your database with customer data, billing that we just discussed right now. So something like this is already stored. It would be a big database, and you start pulling all that information to understand how can we resolve it in the quickest way. But this is just the information of the customer. Do we need this to resolve the ticket? No, this is just part of the entire solution. What else do we need? We need to get all the relevant information of the query, right? So what all information can we gather from our own internal systems that we have? So we could have one section over here whose main purpose is to do tool execution. When I say tool execution, the intent is it goes to different API endpoints that we need to call, or databases again. This database is different from this database. It could be something related to the issue, some recent issue, tickets, documents that we have. So all of this would be over here. So we can start gathering that information also and pass it to the context retriever node. Okay. Now we have this node. So we understand that, hey, to solve this ticket, we need 10 different things, and you can actually create a plan out of this also. So that's another way to design systems like this, but we'll keep it easy for now. So, and we could have a summary of everything to pass, right? So this is where to pass to the next node. Okay, so we have that in everything in the context retriever node. Next what we need to do is it passes on to the next node. It has found all the information. Now maybe we can solve the issue. Okay, maybe we can solve the issue. How can we solve the issue is what we need to figure out. Okay, so this could be your analysis node. So you analyze all the information. Maybe we don't put summary over here. We pass everything that we have and let the analysis node handle most of the stuff. Okay, so what type of analysis we need to do? One would be, does a solution exist, or can a solution be provided based on the information that we gathered. Okay, or, and let's say we are at a stage where this is not a first flow. We have been gathering information, and there has been a long conversation, right, between the AI agent and the user. So is the conversation long and no resolution? So we could have this type of flag where we keep on checking this. And we also, I forgot to mention the sentiment. We need to have a track of the sentiment of the user. It means that if the AI agent is not able to resolve the ticket and the person is getting really frustrated, we can have the sentiment, and then rather than doing all of it again and again for, let's say we still have 2 iterations left on our design, but then sentiment has gone above a particular threshold, just reroute it to a human. I think that would be the best way to not frustrate the customer more. Right, so we got all the information. We go to the analysis node. Now this is where we have the feedback. Okay, what we do is we just add back here. If it's not able to answer the query, it's the first thing, sentiment is down, so we pass it back again and give them this information doesn't satisfy the result and resolve the ticket. So it goes back, it gives the feedback, and this goes on with, now this is where you can add your iteration limit. So we can add the iteration limit over here of the feedback, and that is done over here. Now let's say we are able to come up with a solution. Okay, so now this is where we have a condition now. So let's say we are over here. So can an automatic resolution decision be made, is what we need to take a decision from this particular analysis node. If the answer is yes, I can solve this, I can do it. What do we do? Yes, I can provide a complete response to this. Then what we can do is we could have our final node, which would be a response node, and the task of this response node is to structure your answer accurately, or it could be put all details, then mask all the private information. And this particular node, we do this in this particular node, and then from this, what we need to do is just put an arrow that goes directly to our chat interface, right? Which would be a success. So it comes here, a resolution can be made. it, it's a yes response node, make it beautiful and send it to the user, and we have completed one complete, this a complete cycle has been done. But then if it is now, hey, I'm still not able to figure it out, we are already in our fourth iteration of our entire system, or the person is already frustrated, right? So what we do is we would just redirect everything to a human agent and hope that the human agent can solve the issue, right? So this would be it. But then we should also have a system where we can come to the human agent at any given point of time. Let's say the context is not getting updated, it's the same thing again and again. At this stage also, we can come to the human agent directly. We should add all of these things, so at any stage we are not able to figure out a solution, even from the analysis node we come here, okay? And what we say is a solution is not possible, or I'm not able to figure out, so just pass all context that has been completed till now between the user and the AI agent. You pass everything to the human agent here, okay? And then human agent will be able to solve that issue. So this would be the entire cycle, simple design, which you can come up with multiple nodes. So you have nodes over here, 1 2 3 4, you have like 4 nodes. Then you have, this would be the database tool execution again, along with these, where you're doing RAG. And we need to understand there are multiple things that you can do out of this. Like passing the context is another field where a lot of problems and challenges come across. You can also have a node where you're always checking the token that you have utilized till now, or the cost you are utilizing for this particular system. If it is exceeding a particular threshold, you shouldn't go ahead, just move it to an human agent and maybe that person can solve it, okay? So this is the design for a customer resolving ticket, a customer ticket resolution design. And this is the high level design, and for deep dives you can have one orchestrator agent, and then you can have mechanism into this. You can have systems instruction updated, change the LLM at every node. You can have a different LLM here, a different LLM here. These would be discussed in the deep dives, but this would be the high level design for this particular problem statement. Okay, so that's what I wanted to show you in this video. Thank you.